In this video, we will talk about the text analytics processing pipeline in Python. We're going to cover the three first steps: sentence segmentation, tokenization, as well as part-of-speech tagging. We will be using a package called TextBlob. Under the hood, TextBlob relies on another package called NLTK, which stands for the Natural Language Toolkit. NLTK provides a wider range of text processing algorithms. TextBlob provides a nice API around NLTK. So NLTK is a must if you're working with natural language primarily, but TextBlob provides some quality of life improvement over NLTK. Both of these two packages don't come pre-installed with Anaconda and mainstream Python distribution. So for the very first time, we need to install these two packages. Now I happen to have these packages installed, so it was quick, but usually it takes a minute or so to get these packages installed. The next step, we need to install some linguistic resources that these two packages require. And the linguistic resources depend on what kind of algorithms we want to use and run. And again, many of these algorithms relied on some labeled datasets, some models that they run in the background for them to be able to proceed. And some of these textual resources are large, so that's why they don't come pre-installed or preloaded with a package. TextBlob has a nice way to download everything in one kind of stop shop, which is by importing a module called download corpora and then calling a function download corpora.main. This will basically download all needed corpora, which, as you can see, I already have them, so it was quick, but usually it takes a few minutes to do so. Again, you only need to do this only for the very first time. Once you download the packages and the corpora, you're set. You don't need to do anything for the next time. Similarly, NLTK also relies on different corpora. And if you want to download all corpora, probably it will run you around a 1 gigabyte. So you need to really understand which corpora you need for what processing technique. For us, we only need the tag set for the part-of-speech tagging. So I'm going to download this corpus for now. Again, once I'm done, I don't need this piece of code. I have the packages and the corpora ready. What we need to do now, we need just to import the class TextBlob from the package TextBlob. Okay, so let's take a look at this sentence. Once I finally figured out all life's answer, they changed the questions. Now, let's talk about tokenization and forced sentence segmentation. If I want to break this piece of text into sentences, one way to do it, we can do it with native Python using the string function split. So we can split around a delimiter, for instance, period here, and this will break the sentence to this sentence, which is correct, but it also break it around 5.3, which is incorrect, because this is supposed to be a number. So we can use some of the built-in the string functions in Python, but they only get us so far. A better way to do it is to use the built-in sentence segmentation in TextBlob. So the way we use TextBlob is pretty straightforward. We create a blob object by wrapping the string, passing the string to the constructor of the TextBlob class. Once we do that, we can access many aspects of that text using attributes and function of the blob object. For instance, if I want to access the sentences in the blob object, I can do blob.sentences, and basically this will give me a list of sentences in my blob. And in this case, you can see that I've got two sentences. In this piece of code, I'm just printing them one after the other. But as you can see, TextBlob recognized here that 5.3 is a number and segmented the sentence accordingly. Let's take a look at word tokenization. Obviously, we can do it with Python using the string function split, because by default it's split around white space. So that's split around white space, which is fine for most kind of applications, but splitting around the white space may not always be the good or the correct answer. Now let's take a look at how text blob, if we use word tokenization, treats that differently. I'm going to access blob.words, which basically give me the list of the words in my blob. And you can see here that, you know, the first few words are pretty much the same as what we get to in using the split function. But here comes the difference. Life and apostrophe s are two different words. And this actually makes sense because apostrophe s is kind of a different word associated with life. And as we will see when we do part-of-speech tagging, each one of them has a different role that it plays in the sentence. So we can see here that text blob actually made a better choice than the default split. It also took care of the punctuation mark. You can see that the comma here is not included there because it figured out it's just a marker of a new sentence rather than a character of the word. Same thing for the last period in the text. Next, we may want to be looking at the noun phrases in the sentence. Now, noun phrases are a subset of the sentence that include a noun phrase, which is basically a sequence of nouns. Many often this is used to summarize the text, because often the kind of straightforward summary content of the text is in the noun phrases. The verbs usually indicate some actions, so the noun phrases are sometimes used to pick at, you know, the main highlights of that text. Now, what's really important here is that these algorithms are also optimized for different languages. And this is important. We're kind of assuming that we're treating English text, but if we're not, you know, splitting tokenization also depends on the syntax of the language. So for instance, some languages like in French use comma to indicate a number rather than the decimal point. So that's, you know, one differentiation, and obviously there are main differentiations. So using a package like text blob kind of handle those things peacefully without us having to think about them. Indeed, it also provides a function called detect language, which will basically give you the language of the text by examining the text. And this is kind of a nice function if you're dealing with multilingual text and you probably want to route text to different, you know, processing steps or different workflows depending on the content of the text. So here are some examples. We have a text in French, in Italian, and also in German. Next, let's talk about part-of-speech tagging. Part-of-speech tagging is basically a classification step in which each word is giving a part of speech. Now, part of speech is basically the role that the word play in the sentence. And obviously this has to do with kind of the language itself, the linguistics of the language, so to speak, as well as the, you know, syntax of the sentence. And there are different ways to assign part of speech tags to different words, and there are different algorithms, and there are also different, you know, set of part of speech and set of classes. Let's take a look at one of the universally used one called the UPenn tag set, which TextBlog used. And you can see that there are different part of speech tags, such as some punctuation mark, but more importantly things like conjunctions, numeral, determiner, nouns. Let's take a look. JJ stands for adjectives, NN stands for nouns, so NNP stands for proper noun, NNPS stands for proper noun plural, for instance PDT for predeterminer. We get also a bunch of verbs, RB for adverbs, and a bunch of verbs such as VB or VBD for verb in past tense. So there is an extensive list of these tags. So we don't need to memorize all of the tag set. We have it handy if we want to access it. But let's take a look at applying part of speech tagging to, for instance, this sentence. What I'm going to do here, I'm going to access blob.part of speech tag, and that basically will give us a tuple. For each word we will get the part of speech tag. I'm simply printing them. So that tells us that once is an RB, I is PRP, finally is an RB, figured is VBT, out is an RP, and so on and so forth. So again, if you take a look at the part-to-speech tag here, RB stands for an adverb, PRP stands for pronoun, and so on and so forth. So that basically tells us the syntax of the sentence. You know, figured is a verb in the past tense. All is determiner. Life is a noun. Answers is a plural noun. Proposition. VBD is a verb in a past tense. You know, so on and so forth. And you can see that it got some stuff incorrect, such as anonymous, which it got it as an adjective. So again, I mean, it's not bulletproof, but it gets most the right syntax right in this case.